Today's topic is on frost action. This page is taken from Canadian Foundation Engineering Manual, page 185. You can take a moment to read through it. Frost action has two damaging effects. The first is the frost heave. The second is soil weakening. If not properly considered in the design, frost action can cause problems to roads, railways, pipelines, foundations, and retaining walls. Frost heave occurs in wintertime when the ground is frozen. Soil weakening occurs during spring break when the frozen ground becomes thawed. I have a picture to show these two damaging effects. The bumpy road surface shown in this picture is caused by frost heave and soil weakening. Under freezing temperature and when the ground becomes frozen, frost-susceptible soils can cause significant heave of the ground surface. The heave is caused by growing of ice lances in frost-susceptible soils when the soils become frozen. Because the natural ground normally is not homogeneous, the heave of ground normally is uneven. At the spring thaw, the ice lances melt and become water, resulting in that the soil within the thawed zone is saturated or near saturated, sometimes like a soft mud. The strength of the soil at this time is decreased. Under the traffic loads, the pavement cracks due to insufficient support from the subgrade. In addition, sometimes mud pumps out of the surface through the cracks. You can see the bumpy ground, the uneven, and the cracks. There are three factors governing the frost action. The first is freezing temperature. The second is groundwater. The third is frost-susceptible soils. This picture illustrates the three factors governing ice lancing or ice segregation. The first is freezing air temperature. So under freezing air temperature, the heat in the ground was extracted and the freezing front moves downward progressively. Initially, the freezing front starts at the ground surface and then move downward gradually until reach a certain depth. This depth is called frost penetration depth. Frost penetration depth. The second factor is a frost-susceptible soil. Only frost-susceptible soil will form S lenses. Non-frost susceptible soil will not form S lenses, or the S lenses will be minimal. So ground heave is caused by the growing of S lenses. The third factor is the groundwater table. In order for the S lens continue to grow, there need to be moisture migrate toward the freezing front. Therefore, continuous supply of water is required for the growing of S lenses. So that's the three factors. When the temperature goes up at springtime, the upper portion of the frozen ground is thawed and become very soft or weak due to the excess water after the S lenses melt. The thawed layer would be very soft or weak due to the excess water in the soil. There are two soil properties governing the S lensing or S segregation process. The first one is the capillary head. The second one is permeability. Let's look at the soil between the freezing front and the groundwater table. So the soil located in this zone. In order for the S continuously grow at the freezing front, moisture need to migrate from the groundwater table to the freezing front. In order for the water from here get to here, the soil needs to have enough suction to draw the water from here to here. So this is determined by the capillary head. For example, if the soil can only draw a depth of this much, then the water, the migration to the freezing front will be minimal. However, on the other hand, if the soil can draw water from depths like this, then the groundwater can be continuously drawn to the freezing front. So that's the first factor, capillary head. The second factor is a permeability. For the soil, between the freezing front and the groundwater table. If the permeability is high, then it takes less time for the water migrate from the groundwater table to the freezing front. On the contrary, if the permeability is very low, then it takes more time. The good thing is high capillary head and high permeability normally do not go together. The chart on the right illustrates these two factors. For clays, it has a high capillary action but a low permeability. For the clean gravels and sand, it has a high permeability but a low capillary. Experience showed that the soils have moderate capillary action and moderate permeability are most susceptible to frost action. These will be the soils located in the middle portion of this chart. Those soils include silt, silty sand, very fine sand, silty clay. Those soils have a moderate permeability and a moderate capillary, and their frost susceptibility is the most severe. On the other hand, the soils located at the two extremes their frost susceptibility are negligible.